All right, hello, Olivia. We are reviewing for chapter 1. This is day 1 of review. Tomorrow we'll do some whiteboards and then we'll take a test on Thursday. But this is day 1 of review. Do you guys have a paper that looks like this? It says review at the top and then it says module summary. You can't see what I have on here because I don't have it up. Okay, here we go. Module summary is where we are. Module summary. We're going to write some stuff down on that page. There we go, module summary. Okay, at the top, there are two formulas that you'll have to have memorized for this chapter. Test. 2 things that you'll have to have memorized for this chapter test. Remington, did you hear that? 2 things you have to have memorized for this chapter test. The first thing is the distance formula. The distance formula. We're going to write that down. And the other one is the midpoint formula. You need to memorize those. Okay? And that will be helpful. I'm going to give you some points. Let's do -6 and 5 and 4 and -3. I have no idea. Let's do that. Okay? So we're on the review portion. Ethan, I'm just going to I'm writing down 2 formulas that you will need to memorize for the test on Thursday. Distance formula, midpoint formula. We're going to write the formulas down and then we're going to do that with these points, okay? Distance formula is based on the Pythagorean theorem. Do you remember that? When we do the Pythagorean theorem, it's a squared, b squared, c squared. So we have a squared plus b squared equals c squared. But rather than doing c squared, we take the square root, right? Okay, that's a squared, b squared, c squared. Now, the actual distance formula, I'm not going to write this down. Well, I am going to write it down. You don't write it down, and then I'm going to erase it, is like x2 minus x1 and y2 minus y1 or whatever, right? You subtract the x's, subtract the y's. I do that in my head. We do that in our heads, right? I don't write that part down in the formula because it wastes time when we could just do it in our heads, okay? So I'm going to get rid of that. And let's go ahead and do this distance formula. Let's practice on my points that I have given for you. So these 2 guys right here, in that first bubble, I'm looking at how far apart are -6 and 4. I just made this up. 10. So 10 goes in the bubble, right? How far apart are 5 and -3? 8. So I put that in the bubble, right? Okay, and then I just do the math. So 10 squared is 100. 8 squared is 64. So the square root of 164, or I don't know, 12.8. Check. I don't know. Somebody do it. I know it's a number between 12 and 13. Do you know how I know that? 12 squared is 144, 13 squared is 169, so it's pretty close to 13, right? 12.8? Yeah. Hey, look at that. I'm such a good guesser. There we go, 12.8. Give me at least 1 decimal place when you do distances, okay? 12.8 approximately. Okay, now I'm finding the midpoint, and I'm going to use those same 2 coordinate points, and finding the midpoint is like finding the average. When you're finding the average, you add the x's together and you divide by 2, and then you're going to add the y's together and divide by 2. Okay? All right? So if I add my x's together, I have 4 plus a -6 divided by 2. What's 4 plus -6? -2 divided by 2? -1. Ooh, that was kind of a mess. Okay. Now I do the y coordinates, 5 and -3. So 5 plus a -3. Or -3 plus 5, it doesn't matter what order you add them in, and divide by 2. That is 2 divided by 2, or +1. If I was doing this for a test, you better believe I would probably use a little scratch paper off to the side or something and plot those points and see if -1, 1 lived approximately in the middle. Does that make sense? Okay, I would kind of check it to see if it looks reasonable, all right, if I was doing this for a test. Got it? Okay, so there you go. Questions about that? Midpoint formula. Midpoint is finding average. Average, you are adding. Here you are like subtracting to find the distance, right? Like in the midpoint, you are subtracting -6 and 4 Okay, so you're adding to find the midpoint. All right, I'm going to go through this real quick and show you or tell you what you need to know and what you don't need to know. I am not going to test you on synthetic or analytic geometry, right? One of them was using the coordinate planes. One of them was using like figures and stuff. I'm not going to test you on which one is which because I really don't care. Can I say that? Sure. I will ask you, like on this first bullet point, the axiomatic system has sets of axioms, so like facts that they give you. So I don't know if you guys remember us talking about like the t-shirt example, where like t-shirts were $20 and sweatshirts were $30, and I say this person spent $50, what happened? Like, give me a conclusion. Well, they bought a combination of t-shirts and sweatshirts. Does that make sense? Okay, so I will give you a set or an example like that where you'll have to come up with some conclusions based upon that. So I'll test you over that bullet point. 1, 2 through 1, 4, we have points, lines, and planes. So I'm gonna go down here to the bottom. We've already talked about the distance formula, which is this guy, okay? Points, lines, and planes. Let me do this. Let's say we have A here and B here, and I'll call this line L, and he lives here in plane P, and there's a C there. I don't know, I'm just making this up. Point, line, plane. Let's talk about how you name them, because I'm really picky about names. All right, points have to have capital letters, like A or B or C. Any of those are all naming points. If you just say A, B, or C, I'll know what you're talking about, right? But when we go to name lines, we have to have 2 letters, right? So there's only one line on there. We can either call it L-I-N-E-A-B, or we can call it A-B with a line over top of it, or what else? Line L. Okay, but you have to have the words L-I-N-E in front of it, right? Line L, line AB, or AB with a line over top of it, okay? Plane, I can call this P-L-A-N-E, what? P, or what else? Plane, what? Planes have to have 3 letters, right? ABC. Can you switch those letters around? Sure you can, and make lots more combinations, okay? So either plain P or plain ABC or plain CBA or plain BCA or plain BAC or whatever, however many combinations you want to do. Okay? Got it? There you go. What 2 points are collinear on there? A and B. Are A, B, and C together collinear? No. Even though A and B are, A, B, and C together are not, okay? Let's go up to the top here. Up to the top here. 1, 5, and 1, 6. That's going to be the hardest, probably section on the test, because this is where you do the find the point that's a third of the distance, or find the point that's got the ratio of 1 to 4. We're going to do a lot of those on whiteboards tomorrow. Okay, that's going to be like the most that we spend whiteboards on. Okay, is this section. Okay, so those are going to be a little bit harder. So that's that. Midpoints and bisectors. So we talked about bisectors yesterday. If here is A and here is B, and I say C is exactly in the middle, he is a midpoint, but he is also called a bisector because he separates that line segment into 2 equal pieces, right? And usually they'll mark it like this. If they're 2 equal pieces, they'll put like the tick marks, right? Okay, so midpoints and bisectors, and then we can set those 2 pieces equal to each other, right? Okay, questions about that? All right, this morning what we did was we went through 1 through 17. We skipped number 4, but we did 1 through 17 and we did them all together. Do you want to do them one at a time and then check your answer, or do you want to just do them together? Just do them together? Okay, sure. All right, so make sure that you're understanding what we're doing as we go through this. Here we go. Number 1, they say select the geometric terms that are modeled by the real world objects. Some of these are kind of weird objects. So an electronic tablet, like my iPad, is that a point, a line, or a plane? Probably a plane. It's a flat surface, so I'm going to put an X there. Okay. A pool stick. Line. A scoop of ice cream. Point, I think is what they're getting at. That's a pretty big point, but whatever. A light pole. I don't know. Maybe your scoops of ice cream are smaller than mine, but mine are pretty huge. That's a big point there. All right, light pole.
Point.
Line.
I say line. The pole itself.
Looking at it from the top.
If you're looking at it from an aerial view, it will be a point, but
how
the
often
pole
are you
itself,
looking at-
the pole itself is going to be a line.
Point in the ground.
What about an emoji?
Point.
Could be a point.
I think they're wanting to get at a point,
Yeah.
right?
What
Because
is
it's
a
a
point?
circle.
Yeah.
An emoji is a circle. If you said plain, I'll probably take it. But I'm not gonna ask that stupid of a question on your test, right? I will make sure it's like cut and dry, pretty clear, right? I pick good test questions, I think, most of the time. I don't know. Anyway, number 2. We have an A, B, C, D. A lot of these are multiple choice. Use the figure to name all of the planes that contain point W. Okay? Really, on here, I can only see one plane. There's another one on the back side, but I can only see one plane that contains point W. So they're giving me different names for that plane and saying, do any of these names work? So point W is this guy right here. This front plane, can I name him plane VWY? Can I name him VWY? Yeah, I think so. That will work. Okay, now there's more than one right answer. Can I name him VWX? VWX.
Yes.
X is this guy over here.
Oh.
No,
If
he's like
lined up where
off to the
it's
side, so I don't think he's gonna work. I don't think VWX is gonna work. Okay, what about RYV?
Yes.
R is here, Y is here, V is here. I think that one works. Okay, what about VWZ? VWZ. You see where Z is?
No.
All the way off yonder, so I don't think that's gonna work. What about RYX?
No.
R and Y work, but X is off to the side, so that's not gonna work. So either one of A or C would work for naming that plane. Got it? Okay, let's go to number 3. What geometric figures do the pages of the book represent? Planes. That's what they want by a geometric figure. It is a plane. They're planes. They're intersecting planes. Okay, go to 5. 5 is on the next page. Okay, here we go. All right, read the instructions carefully when I give you a diagram like this. Read the instructions carefully. Find the value of X. We don't have to plug back in because we're only finding the value of X. Okay? A lot of times if they say find the value of X and find the value of AB, I will put them down before I even start the problem so that I know for sure I have to find both. Does that make sense? And I won't forget to find the second one. Okay, they didn't ask for that, so we're just solving for X in this case. Okay, now Q is between P and R. I can see that with my eyeballs. They tell me that. But what I need to know is it exactly halfway between? Is it the midpoint? They don't tell it to me, except they say this. PQ and QR are congruent. I'm gonna put those little tick marks in there. So is he the midpoint? Yeah, he is. He's exactly halfway between. So they can either say that he's the midpoint or they can do that to you and say that those two sides are the same. All right, so what do we do to solve for this? What? Set them equal to each other, right? So 5x minus 10 is equal to, can you distribute the 3 through?
3x 12.
3x plus 12, okay. All right, I'm gonna solve him over here now. Let's subtract the 3x. And I'm gonna add the 10 over. Okay, that's 2x equals like 22. And divide by 2. X is 11. Okay, is that the answer?
Yes.
Yeah, because we didn't have to plug back in, right? X is 11, that is all. Okay, read instructions carefully. If I don't know if he's the midpoint, I gotta do something else, right? Okay, all right, number 6 is a really easy problem, but they don't draw a picture. If they drew a picture, it would be a really easy problem, okay? Let's draw a picture on this. On a straight highway, so we're looking at a straight line, the distance from Loretta's house, I'm gonna do H, and the park, which is over here, is 43 miles. Okay, her friend Jamal lives along the same highway between her house and the park, right? Okay, the distance from Loretta's house to Jamal's house is 31 miles. Okay, question. Does Jamal live closer to her house or closer to the park? The distance from her house to his house is 31 miles.
Park.
He lives closer to the park, right? This is 31, and if the whole thing is 43, then he lives closer to the park. So this is Jamal. They ask, how many miles is it from Jamal's house to the park? Isn't that an easy problem?
Yeah.
But if they didn't draw a picture, so that's the problem. 43 minus 31, 12 miles. Okay, that's a really easy problem, but draw the dang picture and you'll get it, okay? Good? Alright, number 7, find the distance between 2 points. We're gonna do the distance formula. Do you remember what it was? Square root,
No.
this guy plus this guy. A squared plus B squared equals C squared, but instead of doing C squared, you take the square root. Okay? Alright, the distance between 5 and negative 3. 8. Okay, what goes in the second bubble? 4, because 1 and negative 3 is 4. Okay, 8 squared is 64, 4 squared is 16. Add those together and you get 80, but that's not how my answer is represented. They want us to break that 80 down. What does 80 break down into? 4 and 20, but think bigger than that. Think bigger than 4.
80 and 1.
That doesn't work though.
Well, it's right.
What? That's not gonna work either, because you can't do the square root of either one.
16.
So the only options they give to me is that a 4 is on the outside or a 2 is on the outside, right? Matthew's right.
5.
So if a 2 is on the outside, what number was inside of here? 4, right? If a 4 is on the outside, what number was inside of there? 16, does that make sense? Right? So let's try 16. 16 and what?
16 and 5.
16 and 5. Okay, the square root of 16 is 4, and the square root of 5 just stays. So 4 squared is 5, so we're looking at A. Let's say that you forgot that process, or your calculator doesn't do it for you. You could take the square root of 80, get a decimal, take each one of these and get a decimal and figure out which one it was, right? So like on the ACT, if you get stuck and you're like, I don't know how to break it down, you can convert them all to decimals, right? That would work. Okay, that's gonna be kind of a pain in the butt, but you know, whatever. Okay, 4 squared to 5, that's the one you want. All right, true or false? XY, which is this guy. XY is, what is this now? What does this little symbol mean? Congruent, which means the same as YZ. All right, let's figure out XY. X is going from -1 to 7. -1 to 7 is how many units? 8. Then we're going from -5 to 4. That is 9. Congruent? False. Or no. I would probably accept no because I wrote no this morning on accident. Whatever. Okay, good? All right. Am I going too fast?
No.
Not fast enough? Sure? Okay. All right, you don't necessarily have to draw a picture, but I'm gonna. The coordinates of A and B on a number line are -7 is A and 9 is B. Okay. C and D on a number line are at -4, that's C, and 12, so I gotta extend my line out. 12 is D. Are A, B, and C, D congruent? A, B, and C, D. All right, A is -7, B is 9. How far apart? 16. -4 and 12. How far apart? 16. Are they congruent? Yes. Is it A, B, C, or D?
B.
B, because it's 16. It's not -16. It's just 16. Good? Happy with that? That wasn't too bad. You probably could have done that without having to draw a diagram, but, you know, why not? Sure. All right, these are going to be the ones that are the icky ones. Number 10 and 11, these are going to be the icky ones, okay? All right, the coordinate point of X on PQ is 3/4 of the distance from P to Q. P is my start, Q is my end. If I'm going 3/4 of the distance, am I going to be closer to P or closer to Q?
Q.
Yep, I'm going to be closer to Q, so I'm going to be over here, 3/4 of the way, right? Over there. We're going to get an answer and we're going to check it to see if it's, like, accurate. How far apart are P and Q?
12.
12. From -5 to 7 is 12. Okay, now what do I do with that?
Take 3/4.
Take it times 3/4. 12 times 3/4 is how much? 9. And I bet you some of you guys say 9 and you call it a day.
But that would get
That would not be quite right, because where's 9 at? All the way over here. That doesn't even look right, right? If I put where I put my star at the beginning, that doesn't even look right. What did we forget to do?
add it to the
-5 is where we're starting at, and if I go 9 units, where are we going to end? On 4. My star was not quite in the right spot, but he's going to end on 4. 4 is the correct number. Okay, so don't just stop there and call it a day. You got to add it back to where you're starting from. Got it? Good. Okay, that one was a little easier. We're getting a little harder. Okay. Number 11 is going to be maybe a little harder just because we don't have a diagram. Okay, on a number line, let's draw it. On a number line, S is at -3. That's where S is located. And T is located at 9. T is here. S is where we're starting, T is where we're ending. Start and end. Okay, R is located somewhere between there, so that SR to RT is 3 to 4. So this side is 3 and this side is 4. Is he closer to S or closer to T? Slightly closer to S, so like not quite in the middle. A little bit closer to S, right? Okay, there he is. All right. What is this distance from S to this point as a fraction?
3/7.
This was 3 and this was 4, so that's 3/7. That's an ugly, ugly number. That's okay. We're gonna be all right. So 3 to 4, 3/7. You see how we get that? How far is it from -3 to 9? 12. And now what do we do with that?
Put that into 3/7.
12 times 3/7 is how much?
Like 5 and a 7.
5 and a 7th. Yeah. 5 and 1/7. We can go 5 and 1/7. 5.14 is what a 7th is. Something like that, right? 5.14, okay? But I'm not gonna just say 5.14 and call it a day. Although that kind of maybe looks like it might be right, because 5.14 is in between -3 and 9, but it's not quite right. You have to add it to the -3, right? So if -3 is where we're starting, we're adding 5.14, which is how much? Just do it the reverse. What's 5.14 minus 3? 2.14, yep, 2.14. Okay, none of those answers are up there. But, you know what one you're gonna probably select, or you're gonna like want to select first? B, because it looks like 2.14, right? Like 2 1/4, right? But 2 1/4 is not, oh, I didn't mean to fill that in. It's not 2.14, okay? C, it's not gonna be C because that's 1 point something, all right? So my only other options are A and D. How much is A? A is gonna be like 3.3 and 6/7 or something like that. 3.86, okay? So it's not A. Is this 2.14?
Yes.
You betcha, D is what we want. Okay, happy with that? That was a decimal. It was kind of icky. All right, 12, let's go 12. Now we're doing the same thing again, but with coordinate points. What time do we get out of here? We go to lunch at 12:30? Okay,
It is 12:30.
it is 12:30. Should we try to get through this one and then do the rest for homework? Maybe?
We should do 13.
Why?
We should do
Hear me
13
out.
together instead?
I
We
think
go
we
to
should just do the
lunch.
last one.
Hungry man.
What?
Just do the last one by yourself.
Just do the rest by yourself? Stop here? Stop here, do the rest by yourself? Okay, do the rest by yourself for homework. So if you got like 5 problems for homework, we'll check those tomorrow and do some whiteboards, okay? All right. Goodbye, Olivia.